All right, so we are talking about algebraic proofs today. And like Sean said, algebraic proofs is merely we're going to prove our algebra. Pretty simple stuff, right? So we're taking our basic linear equations from last year. We're going to solve them out, but now we're going to justify each step along the way with one of our properties of equality. So instead of just subtracting 10 over, we're going to say, we're going to subtract 10, and we're going to use the subtraction property. So beautiful stuff like that. So we've got a few of our properties to cover. Okay. So this page, the page we get at the beginning tomorrow, and the page we get at the beginning on Wednesday, I'll probably pull them out separately and maybe make a little packet for you guys so you always have something you guys can reference as we're doing our proofs. And then especially for the test, which is next Tuesday. So some of us can get a little redemption from the quiz or redemption from the test. All right, so addition property. If A equals B, we can add any number we want to both sides of our equation without changing the value. Oops, that's got to be B. So A plus B is the same thing as maybe B plus C. Anybody have any idea or care to guess why that's true? How come if A equals B, we can say A plus C equals B plus C for our addition property? What do you think? We're wide awake this morning. So what if I put a number to it? What if I said, if we start out 3 equals 3, okay, A is 3, B is 3, and then we come over here to 3 equals 3, give me a number that can represent C. Okay, so we're going to add 4 to both sides. 3 plus 4 is 7. 3 plus 4 on the right is 7. So my addition property, this is what we do when we're trying to solve for variables. We're trying to move x from one side to the other. We're going to, whatever, if we add the same constant to both sides, it doesn't change our truth value. Okay, what about subtraction? What do y'all think after you saw addition? If A equals B, what's that? A minus C is equivalent to B minus C. My little B got a little eyeball in there. Multiplication, same idea. A equals B. If we do something to one side, it's going to stay equal as long as we do it to the other. It's the same thing as B times C. And then anybody have a guess for quotient? Quotient property? Division property? What do you think? What do you think? What do you think? It's not trying to trick you. A divided by C is equal to B divided by C. So essentially these first 4 are what's happening when we're just moving an equation from one side to the other. So if you guys had a basic 3x plus 7 equals 8, okay, what would we do first? If we're solving for x, a little bit of participation makes this go faster and less awkward. We'd subtract 7 from both sides. So which property of equality did we just use? The subtraction property. Good. So 3x equals 1, and we would say that was the subtraction property. All right? What will we do next to get x by itself? I divide both sides by 3. So we'd get x equals 1/3. What did we do there? Which one of our 4 properties? We did the division property. So we're not changing the math we're already doing. We're just putting a label to it. I know labels are bad. Distributive property, what do you think? If A times B plus C, then what's it become when we distribute something? Remember, it goes into both terms. AB plus AC, right? Hopefully we know that one. Hopefully we remember a little bit. Substitution is where it can get a little tricky because substitution can be confused with the transitive property. Okay? But for substitution, if A equals B, A may be replaced with B in any expression or equation. So if we're taking a number out and switching it back in with somebody, that's going to be substitution. Just like if you think as a volleyball player, your turn on the rotation comes around, they pull you out of the rotation, they put somebody back in your spot. That's substitution. Same thing with soccer. In the 75th minute, we're gassed a little bit. They put somebody with fresh legs in, they take you out and put somebody else back in. Reflexive property for any real number. In this situation, they said A. A always equals A. Any real number will always equal itself. Symmetric property. If A equals B, then we can rewrite that to be B equals A. Can anybody think of an example when you might see that? Because some of us do it. A lot of us, when we solve equations, where do we like our x to be? On the left. So if you got into something that looked like this, 3 equals x, you might be like, oh, that looks a little funky. So if I wanted to rewrite that, I could rewrite it as x equals 3, and then to justify that move, it would have been, I use a symmetric property, coach, that's fine. Because a lot of us don't like the variable on the right for whatever reason. It freaks us out. Okay, and the last one is our transitive property. Anybody remember the transitive property? I know it was a long time ago. If A equals B, it looks a lot like that law of syllogism we just did. And B equals C, then what could I say? If A equals B and B equals C, what could I say? A equals C. Do you guys see how this one and the substitution property can get a little wonky? So just remember, if somebody's being replaced, that's where substitution comes in. If we're using our reasoning and we said, well, this equals that, and then that guy equals the same thing, we can just put them in there. That's different. All right, so these are the main properties we're going to be focused on for our proofs today. When I look at, so we're going to try to name that property. Yeah, name that property. Do, 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 do. No, it's all right. I know, it's okay. It's all right. Yeah, I got to bring some energy for y'all since y'all want to be sleeping on a Monday morning. If K equals 3, then 3 equals K. Why? He said symmetric because they just switched. Does everybody agree? Yes. I mean, I hit a new PR this morning. I'm excited. I did. 285 on the bench. Fill the sleeves, paid off. Because the bench is really just a triceps exercise. My triceps got strong, my bench went up. Magic. And I tried to kill myself with 290, and it didn't. No. It is. I'm sure I can go more if I actually had a spotter. All right, next one. If 2x equals 14, then x equals 7. What changed? What did they do differently? What happened from 2x equals 14 to x equals 7? So they took and they divided both sides by 2. And we call that what? Division property. Good. So when we're looking at these, for you guys, most of the time, I'm going to have the steps filled in. So you've just got to be able to figure out, well, what changed? 10y equals 10y. Same thing equals the same thing. What do we call that? When I look in the mirror, I see myself. I see my reflection. It's a reflexive property. It's like that Spider-Man meme where he's sitting there staring at each other, pointing. It's a reflexive property. It's okay. I'm hip, cool kids. No, I know. It's all right. I've accepted it. If negative 5x minus 1 equals negative 11, then negative 5x equals negative 10. What changed? What is different from our first expression to our second? Who disappeared? Who doesn't exist anymore? The negative 1. What did they do to the negative 1? Did they subtract it? They added it. So to move, if I want to isolate negative 5x, I've got to add 1 to both sides. So what step did they use? Not distributive. Addition. Wow, it's almost like it's straightforward. Hooray. All those nasty nightmares and rumors I heard about proofs. Yay. I know. If 10a equals 2b and 2b equals c, then 10a equals c. Why transitive and not substitution? Okay, so think about it. When substitution, what happens? Somebody gets taken out and replaced. Where does 2b go? He's just dropped, right? So he isn't actually being substituted for anybody. They just drop 2b and go with 10a equals c. That's transitive property. I won't be that tough on you guys when it comes to transitive versus substitution. Because it's easy to mix up. And you're not necessarily incorrect. Number 6, negative 7 times n minus 4 equals negative 7n plus 28. What changed? The parentheses are gone, okay. And they multiplied the negative 7. So multiplication property? Or what? Why distribute, not multiplication? And the easiest one is they didn't do it to both sides, right? So if they don't do it to both sides, it's not multiplication. They just distributed that negative 7, and you're 100% correct, sir. So we've got the distributive property. If 6y equals 24, then 6y minus 3 equals 24 minus 3. What changed? The 2 3's came in there, but what are the 2 3's being done? Subtracting. So it's subtraction property. Number 8. If 10x plus w equals 41 and w equals 1, then we can say 10x plus 1 equals 41. What changed? They added what? Did they really add a 1? The 1 was always there, but what was it before? It was a w. So in the first expression, we had 10x plus w, but in our second one, we had 10x plus 1. What do we call when somebody replaces another? Substitution. Oh no. Number 9, 3x equals 2y, and 2y equals z, then 3x equals z. What do you think? 3x equals 2y, 2y equals z, then we can say 3x equals z. Why? You're right. It is transitive. I'm trying to spell train. It is transitive. They took us down an adventure, and we dropped somebody out of the expression. Number 10, 7m equals 35. Then 7m plus 4 equals 35 plus 4. What changed? They added a 4. So what property did they use? This stuff is straightforward. There will be some that try to trick you. But for the most part, straightforward. Negative 2c equals 18, then 18 equals negative 2c. What do we call? We just flip it around. Symmetric. That one, right? Symmetric property. Given 3x squared plus 1, if x equals 5, then we can say 3 times 5 squared plus 1. What'd they do? What changed? They replaced the x with 5. And what do we call it when somebody replaces another? Substitution. If m equals negative 2, then 8m equals negative 16. This is a little tricky. What changed from m equals negative 2 to 8m equals negative 16? They put an 8 there. But in order to be justified, they've got to do it on both sides. Did they multiply both sides by 8? Did m get multiplied by 8? Negative 2 get multiplied by 8? Yes. So what are we calling that one? Multiplication. Last one. 5x plus 8x equals x times 5 plus 8. What changed? They did what? They put the x on the outside. So they undid something we did earlier. Normally we'd call this factoring. What is it? Think of it going from the right to the left. What'd they do to get from x times 5 plus 8 to get to 5x plus 8x? Not symmetric, distributive. Don't get hostile over there at me. All right. So we've learned our properties. Let's put those rascals to use. Coach, what in the heck is a two-column proof? Well, ladies and gentlemen, the two-column proof is a common format in which we're going to use it to help organize our thoughts. The statements are listed on the left. And the reasons, what's going to justify our statement, are listed on the right. You're like, well, what can we use as a reason? Just because? Unfortunately, not no more. So what can we use? We can use properties, definitions, anybody want to guess the other two? Got an idea? Postulates. Come on, the last one. Y'all got this. We got it. Come on. We learned postulates in what last week? 2 weeks ago. Theorems. Man. So we can use properties, that whole last page, definitions, postulates, and theorems. Here's the cool thing about proofs. They're always going to give you the first answer, and they're always going to give you the last answer. You just got to figure out the middle puzzle in between. So number one, given 4x minus 1 equals 27, they want us to prove that x equals 7. The first line of your proof will always be the problem, the given, and the reason we have it is because they gave it to us. So look at that. You've already got 33% done. Hooray. All right. So again, most of the time for you guys, you will have what's happening on the left. On algebraic, you'll have a little bit more able to fill over here. What's happening on the left, and then you're going to tell me why they did this, what is their justification, what is their reason on the right. And it's going to go a long line of me asking you what changed. So when we look at our number one, our given, 4x minus 1 equals 27. What changed from statement 1 to statement 2, 4x equals 28? What is it? They added 1. So what property are we going to use? Addition. The addition property. So now that we've gone step 1 to step 2, our final statement should always match our proof statement. So what goes in the last box, whatever our final statement is, should always match what they want us to prove. What is it? They divided 4 into both sides, so the division property. And just like that, y'all did your first proof. Yes. Get fired up, people. It's a good thing. All right. It's okay. I'll bring the noise. I'll bring the thunder. Given a divided by negative 6 plus 2 equals 5, prove a equals negative 18. So what always comes first? The problem, and the reason for that is, well, they gave it to me. It's my given. So looking at from step 1 to step 2, what'd they do? They subtracted 2. What do we call that? Subtraction property. Spell subtraction right, math teacher? So now we've got a divided by -6 equals 3. How did they get a by itself? They multiplied both sides by -6. So we got the multiplication property. Bueno. Feeling a little bit more confident in this? Not as bad as we thought it was going to be? Uh-oh, we got 4 statements now, though. It's always going to get more difficult. So given 9 times 2x minus 3 equals 63, prove that x equals -2. Remember, our first statement will always be what they give me. The final statement will always be what they want me to prove. So looking at our first step, -9 times the difference of 2x and 3 equals 63. What'd they do? What changed? They distributed the 9. So we've got distributive property. Step 3, they went from -18x plus 27 equals 63 to -18x equals 36. What changed? They subtracted 27. And then finally, they went from -18x equals 36 to x equals -2. Division. Good old division property. All right, we're going to skip the next page. Actually, let's do number 5 before we skip, because it's got something in there you'll see. Let's do number 5 together. Given -7x plus 2 plus 4x equals 6 times 2x minus 4, prove x equals 2/3. What always comes first? The given. The given will always come first, and what always comes last? What they want me to prove, the answer. So we've got -7 times the sum of x and 2 plus 4x equals 6 times the difference of 2x and -4. How did they go from that to -7x minus 14 plus 4x equals 12x minus 24? What'd they do? They distributed. So that's a distributive property. The next one is what I wanted us to make sure we talked about. They went from -7x minus 14 plus 4x equals 12x minus 24 to -3x minus 14 equals 12x minus 24. What'd they do? What's that? They combined -7 and 4x. So what do you think that is? Okay, so that's why I wanted to talk about this. He says it's addition property. Can anybody tell me why it's not the addition property? What's that? You didn't add what to where? You're in the right ballpark. You're in the right area. So why is negative 7x plus 4x not addition property? Our addition property, what did it say? A plus C was the same thing as B plus C. What are we doing right here? Are we adding the same thing to both sides of our equation? No, we're really just tidying up the left. We're combining like terms. Combining like terms is what this is called. So if we're not going across the equal sign, we are not performing a property of equality. So this is called CLT, combine like terms. And I set you up for that, and it's not your fault, because I knew what people were going to say. You just happened to step into the bear trap first. You're welcome. All right, so we combined like terms and got to negative 3x minus 14 equals 12x minus 24. What did we do next? What changed? Who moved? What's different from 3 to 4? They subtracted a 12. In step 3, 12x is on the right. Step 4, there's no x on the right. So they subtracted a 12, so from both sides, what do we call that? Subtraction property. Then from negative 15x minus 14 equals negative 24, they got negative 15x equals negative 10. They added 14 to both sides, so we call that the addition property. That was wonky. And then lastly, negative 15x equals negative 10 became x equals 2/3. Division. I would have liked them to draw that out and then we simplify, but they didn't, and that's okay. I didn't realize they started the blank ones on this page. That's perfect. I'm going to do some blank ones on this one. All right, now, instead of doing the math for us, they're like, you guys are confident math students. Y'all can solve linear expressions for a variable. So let's fill out our own two-column proof. You can do one step at a time, labeling each one as you go. But what I like to do is I like to do all the math first, and then we kind of just come back around and do what we just did. But if you want a statement, reason, statement, reason, statement, reason, that's also okay. Does that make sense? It's whatever you want to do. So we'll do 6. The way I like to do it, we'll do 7 statement reason. So what always comes first in a two-column proof? The given. So what's my given? 3x plus 1 equals negative 14. How do we know that information? It is given. So when we write our proofs, we're always going to put a number. And the reason is it helps us organize, because sometimes our handwriting isn't as good as it needs to be, and we might get lost. So we always have the first line because that's our given. Okay. So what do you guys want to do first? We're going to subtract 1 from both sides. So what's that give me? 3x equals negative 15. You're right, negative 15y. When the signs are the same, you add them and keep the sign. If the signs are different, you subtract and keep what? The bigger sign. It's no, because to move it from the left, we've got to subtract it. Because what happens on the left? We want it to become what? 0. So if it's a plus, we've got to subtract to make it 0, and then negative minus a negative, we add them and keep the sign. Okay, so now we've got 3x equals negative 15. What are we going to do to get x by itself now? Divide both sides by 3. So x equals negative 5. Is there another step? Why not? A, we solved it, and B, what did we prove? X equals negative 5. Did we just prove that? So can we stop? Yes. All right, so what's our reason for number 2? How did we get from number 1 to number 2? Subtraction property. And then how did we get from number 2 to number 3? What changed from 3x equals negative 15 to x equals negative 5? We did the division property. Number 7, given 2 times the difference of x and 9 equals negative 10, prove x equals 4. What do you think? What always comes first in a 2-column proof? The given. 2 times x minus 9 equals negative 10. How did we justify that? How do we know that information? They gave it to us. I should always get at least the first part of a proof right, even if I miss a day of school. All right, we're trying to solve for x. What do you guys want to do first? And this time, remember, we're going to justify as we go. You want to distribute, so we're going to take that 2 and multiply it into both terms of our binomial. So 2 times x, 2x, 2 times negative 9, negative 18. And what justification are we using there? Distributive property. All right, what are we going to do next? We're trying to solve for x. We're going to add 18 to both sides. Because our ultimate goal in solving for x is what? Yeah, isolate that pesky variable. So if I add 18 to both sides, what do I end up with? 2x equals 8. What's my justification? What allowed me to do that? What is it? Addition property, good. Hey, we're not quite at our proof statement yet, so what do y'all want to do now? Divide both sides by 2. So after I divide both sides by 2, what do I get? X equals, and then what's my justification for that action? The division property. Don't die on me, son. that a sneeze or a cough? Both? That's pretty awesome. All right, let's do one more. And then I'll set you free to start your homework. Let's do number 11. 11. And then I'll set you free. You'll have the last 10, 15 minutes of class to work on your homework. Hopefully knock out most of it, right? Maybe? Maybe. All right, what always comes first in our two-column proof? What they gave me. 14 minus 2 times the sum of x and 8 equals 5x minus the difference of 3x and 34. How do we know that piece of information? They gave it to me. Ooh, this is a good one. I like this problem. All right, what do y'all want to do first? What's up? Distribute. Now, the big thing when I distribute this is, what are we multiplying by? What's that? -2. And then on the right side, what are we multiplying by? There's nothing there. What are we multiplying by? Why do y'all think it's important that I boxed up those negatives? Yeah, when I multiply, I don't want to forget them. So when I multiply, when I distribute, I'm distributing by -2 on the left and -1 on the right. Oh, Peter. So number 2, 14, what do you got? -2x. And then -16 equals 5x minus 3x plus 34. What's our justification? Distributive property. All right, what do y'all want to do next? Yeah, combine like terms. We want to clean up our left side and our right side. So it looks like we've got a couple of constants on the left and a couple of linear expressions on the right. So when I clean that up, I get -2x minus 2. 14 minus 16 is -2. Equals 2x plus 34. And like she said in the back, we're going with a big old CLT sandwich. Combined like terms. What do y'all want to do next? This is where you guys could have something different than what everybody else has. And that's okay. What do y'all want to do next? You want to add 2 to both sides? So you're going to take the guy on the left and add it to the right? That's fine. So we add, because you like the little positive numbers, right? That's fine. So I get -2 equals 2x plus 34. What's our justification? What did we do? What did we change? We used addition. Yep, addition property of equality. Thank you. Right. What are we doing next? subtract 34. So we get negative 36 equals 4x. What do we call that? What's our justification? Subtraction property. We're not quite there yet. What do we got? What is it? Divide. We're going to divide both sides by 4. So we get negative 9 equals x. Now, because we added x in that first one, does this statement look exactly like what they want me to prove? No. So how can I make it look exactly like what they want me to prove? I'm going to switch it around. And what property allows me to do that? What is it? Symmetric. Good. All right. You guys can get going on your homework. It's a lot like what we just did. One, two, three, four, five, 6 whole problems tonight. Devastating. Here's